A very good morning to all of you. Today we are going to cover a new topic that is known as Zener diode. This is one of the type of diode. In last lecture we covered the mechanism of breakdown, and there are two types of breakdown mechanism. One is Zener breakdown, one is avalanche breakdown. So in this topic we are going to cover Zener diode. Zener diode is a type of PN junction diode which is specially doped to work in a reverse bias condition. A Zener diode is a special type of diode designed to reliably allow current to flow backward when a certain set reverse voltage known as Zener voltage is reached. This is a symbol of Zener diode. This is a P-type semiconductor. This resembles N-type semiconductor. This is the anode and this is known as cathode. So this is a general definition of a Zener diode. Circuit diagram of a Zener diode is connected in series with resistance, which is also connected to the battery supply. A Zener diode is a heavily doped to reduce the breakdown voltage. Okay, so we specially design Zener diode. We heavily dope the Zener diode so that we can reduce the breakdown voltage. This causes a very thin depletion region. The Zener diode breakdown characteristics are determined by the doping process. All the breakdown characteristics determination of the breakdown characteristics is by doping process. Now the second is working of Zener. Its working is very important. When we talk about the forward biasing of Zener diode, biasing is the a physical arrangement of the circuit. So when we adjust the circuit in your forward biasing means P-type semiconductor is connected to the positive terminal and N-type semiconductor is connected to the negative terminal of the battery. It acts as a normal conventional PN junction diode. Okay, so that is as we supply positive is connected to the P-type semiconductor, so we start supplying the positive supply to the circuit, and from here the negative electrons is uh, sending towards the N-type semiconductor. The concentration of holes over here is increases and concentration of electrons will increases over here, due to which depletion regions start decreasing. So in short, as we increase the voltage of the battery, the depletion region the size of depletion region reduces with the increase in voltage. Okay, so this process is similar with the conventional PN junction, and the characteristics, the type of characteristic we obtain here is similar to PN junction. Now in case of reverse biasing, that's why we specially designed Zener diode to work in a reverse biasing. In case of reverse biasing, the P-type semiconductor is connected to the negative terminal and N-type semiconductor is connected to the positive terminal. As we start supplying the voltage, suppose initially we are assuming it is 1 volt. So initially what happened, the positive holes over here is attracted towards the negative terminal and negative electrons are attracted towards the positive terminal, due to which depletion region increases. So as we increase the voltage, the depletion region increases with the increase in voltage, due to which after some time the flow of electrons will stop. Initially a very small amount of leakage current start flowing, but at some time a voltage will reach. At some time, suppose we assume that the maximum voltage for Zener diode is 5 volts. So at the time of 5 volts, the energy is so increased that the electrons generated, the positive hole generated by this holes and the negative electrons are generated by this negative terminal are the power of this voltage is so high that they will supercome this depletion region, and the conduction will start immediately take place at this maximum voltage. So here it is, as a result depletion region increases with the increase of battery voltage. After this point, a point reaches where the voltage become maximum and we obtain a breakdown immediate break voltage, which results Zener breakdown, and here we obtain Zener breakdown. The characteristics we obtain here is like this. This is the x-axis represents voltage, y-axis represents currents. This is the region for forward biasing and this is for reverse biasing. Okay, in case of, as you see in the diagram, the forward biasing is similar with the PN junction, that is at the volt of 0.3. In case of germanium, the current start flowing. In case of silicon, after 0.7 volts, the voltage current start flowing. Okay, but in case of reverse biasing, initially we obtain a small leakage current, but after a point of knee point at Vz, we get the current from minimum voltage, minimum current to maximum current. This is Zener constant voltage, and this is known as Zener breakdown, and the region is known as Zener breakdown region. Okay, the similar graph we obtain in case of avalanche, but there is a small change in avalanche current, that is there is a gradual decrease in current. Okay, so I hope you understand the topic. Thank you very much.